My name is Nur Nabila Fatia binti Sutia, S70104. For my part, I will explain the overview and the background of this study. This research focused on the inland port and the issue of the decarbonisation in the logistics sector. The inland port played an important role in reducing congestion at the seaport and improving the cargo movement to the inland area, especially as the trade volume continues to increase. However, inland port also rely heavily on the diesel power equipment like road transportation and energy incentive warehousing, which is contribute to the high carbon emission. Therefore, decarbonisation has become an important issue in import development. In this study, PERLIS inland port is selected as the case study because of it is the newest inland port in Malaysia, and it has strategic location to support cross-border trade between Malaysia and Thailand. The objective of this study are to access the current decarbonisation initiative at the PERLIS inland port and identifying the challenges in adopting low carbon practice. And the purpose strategic to support the transition toward the more sustainability and environmental responsible to inland port. That's all. Thank you.
Assalamualaikum and very good morning to doctor and my fellow friends. My name is Alicia Fika binti Suhaidi. My number metric is S70144. Today I'm going to present about the problem statement in inland port. First of all, I will start with the introduction for problem statement. Although inland port play a growing role in supporting Malaysia's logistic efficiency and reducing congestion at seaport, their operation contributes significantly to carbon emission through diesel power handling equipment, high emission road transport movement, and also energy intensive warehousing activities. The PERLIS inland port is an emerging logistic hub in the northern region currently operate with conventional process and limited adoption of low carbon technologies, resulting in a footprint that remains largely unquantified and unmanaged. At the national level, Malaysia also have committed in reducing the greenhouse gas emission intensity at port by 45% by within year 2030. Yet policy implementation and decarbonisation initiative for inland logistic nodes remain fragmented with no specific framework to guide inland port sustainable transition. Also, this gap can create uncertainty for stakeholders and limit the port readiness to meet future environmental standards and industry expectation. Therefore, a systematic investigation is needed to identify the source of the emission, evaluate feasible decarbonisation strategy, and also to determine how PERLIS inland port can align its operation with Malaysia's low carbon development agenda.
This study has three main objectives. First, to explore the current status of decarbonisation initiative at PERLIS inland port. Second, to identify the key challenges that hinder the adoption of low carbon practices. Third, to propose suitable strategy and pathway to support PIP transition toward a more sustainable and environmental responsible inland port.
Thank you, Amir Ashraf, for the research objective. Hi, my name is Nopatia Nazla Peti Shahrin, S70028. Today, I will present the literature review. First, concept of inland port. From the previous research, specialized inland logistics center located away from coastal port, also called dry port, facilitating cargo transfer, storage, and distribution. Next is function of inland port. Inland port acts as connector hub between industrial regions and seaport, provide custom clearance, warehousing, container handling, and multimodal transport, redistribute import or export to improve cargo flow and reduce seaport congestion. Inland port is really important in Malaysia. For example, PERLIS inland port PIP, ancient cross-border trade, and logistic efficiency with Thailand. Lastly, inland port linked to accessibility is support efficient cargo movement, reduce bottleneck, and enable just-in-time delivery, contributing to more sustainable logistic operation. Next, carbon emission inland port, generated from cargo handling, truck, rail, and energy use. First is diesel equipment, such as forklift, crane, truck. This is a measure of CO2 sources. Road transport, highest emission, especially cross-border truck. Rail, lower emission, but still contributes to diesel power. Factor affecting emission, equipment age, fuel type, efficiency, and automation level. Challenges, limited renewable energy, efficient cargo flow, low accessibility awareness. Example of inland port in Malaysia, PERLIS inland port PIP. That's all for me. Thank you.
A very good day. My name is Anagistri Deva Mohanaraj, metric number S70246. Now, I will explain low carbon and green technologies for inland ports and the policy and regulatory framework for port decarbonization in Malaysia using PERLIS inland port as an example. First, low carbon and green technologies are important because they help inland ports reduce carbon emissions from daily operations such as cargo handling, storage, and transportation. Many inland ports in Malaysia are starting to adopt renewable energy, especially solar power, which helps lower electricity costs and reduce their carbon footprint. Inland ports are also using energy-efficient equipment and digital systems to improve efficiency while supporting better environmental performance. The Green Technology Master Plan encourages the adoption of low-carbon technologies and environmentally friendly solutions to support port decarbonization. In addition, green financing mechanisms such as Green Sukuk provide financial support for sustainable port development and the adoption of cleaner technologies. Moving to the policy and regulatory framework, Malaysia has introduced several policies and strategies to support port decarbonization. These policies encourage inland ports to use cleaner energy, control emissions, and follow more sustainable operating practices. The Green Technology Master Plan also provides clear guidance for ports to move towards greener logistic operations. Recent studies shows that Malaysian ports are starting to implement environmental monitoring, green practices, and carbon reduction initiatives, which inland ports like PERLIS inland port can follow. Malaysia is also exploring green financing options to support infrastructure upgrades related to decarbonization. In conclusion, the combination of green technologies, supportive policies, and financial incentives helps inland ports in Malaysia move toward a more sustainable and low carbon future. Thank you.
Assalamualaikum and very good day everyone. My name is Muhammad Faznil bin Dimas, metric number S70210. So next, I'm going to continue on the methodology of this research. This study adopts a mixed method approach with a strong qualitative focus using an in-depth case study of PERLIS inland port. This approach was chosen because decarbonization involves operational practices and management decisions that require detailed, descriptive analysis. The research uses a qualitative case study design, which is focusing on PERLIS inland port as a single bonded system. This allows us to capture real operational conditions and stakeholder perspective related to sustainability and low carbon initiative. For primary data collection, semi-structured interviews were conducted with the operation manager of PIP as the key respondent. A supplementary survey was also used to gather broader insight on environmental practices and readiness for decarbonization. Secondary data were collected from academic journals, government and policy reports, industry publications, and inland port development guidelines to support and contextualize the findings. And finally, the data were analyzed using thematic analysis, where responses were coded, grouped into key themes, and interpreted in line with the research objectives. These methods ensures the findings are systematic, relevant, and aligned with the study aims of assessing decarbonization readiness at PIP.
In result and finding, I will present the qualitative findings from our study on decarbonization initiative at PERLIS Inland Port or PIP. The analysis is based on thematic insight gathered from expert interview. For the objective one, which is current status of decarbonization, PIP has already taken basic steps such as switching to LED lighting, applying energy-saving measure, and improving equipment maintenance to reduce fuel use. Electrification of yard equipment is being considered, but it's still at the planning stage. Overall, readiness level is moderate, while there is awareness of the importance of decarbonization. Progress is slowed by resource and technical limitation. For objective 2, which is challenge to low carbon practice, we explore the challenge hindering adoption. The biggest barrier is financial. Green technologies require high upfront investment, and diesel equipment remains cheaper and more accessible. Operational constraints also exist, as alternatives are not yet widely available. Finally, there are human resource gaps. PIP currently lacks technical expertise in carbon management and advanced green technologies. The last objective, which is strategies for sustainability, we look at the potential strategies to support sustainability. Transitioning to electric forklift and solar energy generation would significantly reduce fuel consumption. Government support such as initiative, grants, and tax relief is critical to accelerate adoption. Partnership with logistic companies such as universities and technology providers can help pilot innovative sustainability projects and share expertise.
For Objective 1, the finding indicated that PERLIS Inland Port has a moderate level of readiness for decarbonization, while electrification of yard equipment is planned. Current action remain the instrumental, mainly focused on basic energy efficiency. This reflects common trend among inland port globally, where progress is limited by resource constraint. For Objective 2, the main challenges are high capital cost, continued resilient on diesel power equipment, and a lack of technical expertise. These barriers are multidimensional, involving a financial, technical, and human resource limitation. For Objective 3, the study purpose adopting electric equipment and renewable energy, supported by government, incentive, and strategic collaboration. Overall, a holistic and integrated approach is required to move from incremental action to systematic decarbonization.
In conclusion, this presentation highlights that the PERLIS Inland Port PIP plays many important roles in the network system, especially in the logistics sector in Malaysia. However, its reliance on conventional process and equipment is very high and also contributes to a significant increase in carbon in the port area. This is because this study has shown that many low-carbon technologies can be applied, for example, renewable energy system, energy efficient equipment, and digital-based operation need to be implemented. This can help improve various efficiency while also reducing all negative impact on the environment. In addition, success in decarbonization also requires process re-engineering, fundamental support, and also a very active engagement from relevant stakeholders. Finally, by implementing various structured strategies, they must be aligned and accurate with the national goals regarding the carbon reduction. The PERLIS Inland Port PIP as one of the potential centers can become a hub in the modern and environmentally friendly inland logistics sector, competitive and also environmentally responsible in the country. especially in the logistic field at the port. This implementation must become a sustainable practice. It's not only address a various environmental challenge, but also position PIP as a model for inland port with low carbon performance in Malaysia and the surrounding regional areas.